Welcome to clickmyproject.com.
Our product title is Precharge-Free Low Power Content Addressable Memory. Now we are going to discuss about our product abstract. A content addressable memory can comprise memory elements usually built with the 60 SRAM cell and circuit to compare search bit against the store bit. We are implement the NOR and NAND type of MLs and the two basic process of this our product. The NOR type match lines, the compare the two pair of NMOS are connected in this series with the SRAM cells, and then the such the gate of the one pair of the NMOS are connected to the stored the one data bit, and the complement of the search bit lines, the gate of the another pairs of NMOS are connected to the complement of the stored in the bitwise and searching bit of the bit lines. For every pre-cycle, the process of the ML will be pre-charged if all the bits of word bit and the search bit of the MLs will be hold on the pre-charge values. After going to the NAND type match line, this gate of the NMOS and is connected to the stored bit, and the gate of the another NMOS is connected to the complement of the stored bit, and that respectively the source and connected to search bit and the complement of the search bit line. After the CAM is free of the drawbacks of the charge sharing in the NAND and AC current of the NOR type of CAM. CAM architecture, that literature of the pre-charge MOS connected all the ML process, the pre-charge of the evaluate all the ML for the respectively the pre-signals, and few works based on the breaking down of the complete word in the segment. After the management of the pre-computations and NOR and ML and NAND type of process hybrid, the majority of the suffer from the basics of the process. Let we see our product flow diagrams. First of all, we design the 60 based SRAM CMOS design the SRAM data register memory in the 60. The design is stored with a single bit value, the based on bit line and write line input. This design is consists of two inverter cross connections. This connection is maintained to the given input data. The write line is set to 1, then to get the data to across the inverter circuit connections. This designed 4-bit data register using the design. After the process, we are comparing the condition for the RAM data equal to the CAM data. The process we can design the CAM CMOS design. We design the 80 XOR CAM CMOS design. This design consists of the two control line and the selection line, the bit line and the control line of the CAM cells. This process used to find the address bit line locations and to check the address level and apply the evaluations logic functions. It contains the CAM block that operates using the self-timed control the input controllers, and the process we can implement. So if you know the bit on the selection lines of the process, it from the beginning, the CAM array of the cells, the grouping from to matrix, we are combining the level of the XOR and NMOS levels. After we getting the scan based enable functions, this process the scan based enable process to find out the CAM cell array to result to apply the CAM data and RAM data. The XOR gate function to match the SRAM process after getting the CAM data and give the invert output to check all the row CAM data to data register input data bit to activate the ML function process. This process we get the output. So after the location the relocated of the every process, we get the result, and then we are going to the performance process. The clock matching the enable functions after get the every bit and the XOR and NMOS process, we get the enable process after matching the getting the process. After we are going to the final performance analysis. This final output to identify the content address effectively and to increase the ML check process time. This process the consider the power consumption level and to check the ML delay time also. Now we can see our process running processor. We can implement our process the content addressable memory in a Tanner tool. We split the cell 0, cell 1, cell 2, cell 3. This process we have each and every model process. We have first we have designed the 60 SRAM process. After we implement that 83 SRAM process, the combine of the CAM process, content addressable memory process, with each and every blocks we have improved the XOR and NAND process with the ML functions. Now we can open in the cell 0 process is a 60 RAM process. We can go into the simulate the process. We have the process the transient Fourier analysis. We have some give the input processor for the nanoseconds for the time stop line. After the maximum time step 1 nanosecond, print start time zeros, print time setups 1 nanoseconds, use initially conditions false. The process we have mandatory give after we are going to the running the process. Then just like I'm going to running the process, we get the output for the voltage process for the X60 SRAM process. After running the process, we get the voltage model of we edit waveform viewer for the input voltage and output voltage. We split the connectivity of this process. We can enable the first whole cell zeros for the enable all voltages output. We can give the split they compare to the each and every bit for the 60 SRAM process. After the process completed, we are going to the cell 1 for the X80 process. After this process, we are running this level of the process also same the simulation setup. We can give the transient setup those Fourier analysis the giving the datas. After we are going to the running the process for 80 transistor. Let's we see the 80 transistor process. We get the output result we can see. So automatically open the W edit waveform viewer. We get the split the output for the process. So each and every input process is enable 5 voltage. We can get the output voltage of a 5 voltage. The comparison of the 80 transistor of the ML process in here, the little bit of the XOR and NAND process, we get the output result in the win and bin process. After finishing this process, we can go into the implement for the CAM process. So now only we can the process for the CAM process. So we can give the process after the same process simulation process. We can give the mandatory of this input parameters values. After we go into the running the process. So now I am going to the running the process. Here the CAM process, the storage associate memory process, we get the result in here. We split the storage functions. Every bit we can give the ML process and the win process. We get the output in the little bit of the motions. We get the enable of the basic of the X60 and 80 process in the with ML and XOR and NAND process. We can combine the associate memory with the addressable process in the same like the RAM and CAM process. So we have implemented the ML process with the scanning the same result for the every sequence. We get the output process, we get the result. After we go into the cell 3 process, we can implement the lot of CAM cell process. With every block we store the same RAM little bit the every associate memory process. We can implement the same method. We can give the same method transient Fourier method. After this result we get the for the content addressable memory in the memory allocations, which process we get the in the node and allocation of the memory the process. After we split the process, the same allocation of the memory input and random of the memory. After we finishing the process, we can see the each and every CAM process which whatever the store in the allocation speed increases. That's a process. This is finished. Thank you for viewing our product website.